Okay, so first up we have descriptive statistics. So there are 5 different descriptive statistics, and these are mean, median, mode, standard deviation, and range. So the mean is the average of all the numbers in the data, and is most commonly known as the average. So to get this, you add all the numbers up in the data set, and you divide it by how many pieces of data there are, so how many numbers there are. The median is used to show the middle value of the data set. So for example, if you had the numbers 1 to 10, then 5 would be the median, as that is in the middle. The mode is the most common value within the data. So for example, if you had 6 random numbers and then there was 2 of one number and there was 1 of the rest of the numbers, then the number that there's 2 of would be the mode, as it's the most common. Standard deviation is the range around the mean of the value in the data set. The range is the difference between the highest and lowest of numbers. So inferential statistics are a test for relationships or differences in a data set. We use inferential statistics to prove that a relationship or difference was not down to chance. To determine this, we use the value of p being less or equal to 0.05. This means that there's only a 5% chance of the results being wrong or being down to chance. So to get all this, there's 4 tests. The 4 tests are Pearson's product moment correlation coefficient, Spearman's rank order correlation, the t-test, and the Mann-Whitney U-test. So the Pearson's test is a parametric test that is used to test for relationships. The correlation shows the strength of the relationship, which is also known as the R-value. The test is used to identify the correlation of the outcome is significant, and also the test tests two different variables. The Spearman's test is a non-parametric equivalent to the Pearson's test. It is used when the data is ranked, meaning that it uses ordinal data. The use of the test is that it searches for a relationship between the 2 different data sets. The test uses the R-values to determine the significance of the relationship. The t-test is a parametric test that is used to test for differences. It has a dependent variable, which is one group or the same, and also independent variant, which is 2 groups or a different thing. The test is only for 2 data sets, in which it analyzes the mean of both of them. The variation of the data must be similar for this test to work. The Mann-Whitney U is a non-parametric equivalent to the independent t-test. The test is used with ranked data or data that is not normally distributed. It tests the significance of the 2 independent groups. It also looks for the mean, or finds out the mean of the 2 different sets of data, meaning that it must require 2 samples of the same size, as this will affect the mean results. The test produces a U value, which is used to determine the level of significance. So next one to our research project that we did. So the research project that was conducted is called "Is there a difference between basketball and netball shooting ability in my tutor group?" The data will be collected via a field-based method where we will use a sports tool to find out the data by using the basketball and netball hoops. So now we're going to go to Excel, where we have all of our data that we found, which is here. So we're going to go into a bit more depth. So we're going to data analysis. We're going to go on to the top, descriptive statistics. Press OK. So our input range is going to be all of this data. I want to include the labels, and I want summary statistics. It's okay. Get this, which we shall rename to descriptive statistics. It's a bit easy to see. I'll also make this bold. So just right off the bat, we can see that the mean is higher on the basketball, than it is on the netball, which means that well, the average on the basketball was higher than netball. And if you also look at the sum of the basketball was 101 compared to the netball being 82. So more shots on basketball were converted than the netball. So now we're going to make a bar chart for this. We're going back to our original page, and we're going to select our data, insert a bar chart. I'm going to move this to its own page. We'll call it bar chart. So I'll rename the chart a sec. And we'll rename it to difference of basketball and netball shooting ability. I'm also going to add in our axis titles. So our axis at the bottom is going to be called participants. Our axis on the left will be called successful shots, or number of successful shots. So as you can see on the graph again, that it looks like the majority of the people were more successful in the basketball, which is the blue. So we can see most of them are less higher. All of these are higher. Basically, someone got the same there. However, there are a few outliers which got better at netball, which was like number 11 and number 22. Also number 14 as well. So there are a few, and number 10. So there was a few people that actually got better on netball, which would make it a bit closer. However, the majority of people got better on the basketball. So now we're going to run a t-test. To do is we're going to go back to our original sheet, and we're going to go back to data and data analysis. I'm going to scroll down to t-test 2 paired 2 sample for means. We'll press OK, and now we're going to get our data. So select basketball for first variant, or first variable, sorry, and then we'll select our netball for the second one. We want to make sure labels is selected and that the alpha is set to 0.05. We'll press OK. So I'll make this a little bit easier to see. That. So as we can see, we can see clearly the result is not below 0.05. It is at 0.14271492 because we're looking at this this value here, this result. This means that the result of the data that was collected is not significant enough, and it would be classed as down to chance. So now we're going to look at why we chose the t-test, or which test you would need to choose for different types of data or tests that you're doing. So as we're using the inferential data, we begin to go. Oh, this is just a diagram that we use, sorry, to decide what types of data what types of tests we need to use for each type of data. So as we use inferential data, we begin to go down this route. And now that we need to see if the data is compatible with a parametric test or not, or a non-parametric test. So the non-parametric test require a nominal or ordinal data for this test, and the parametric test need to be interval or ratio data. So as we have we have ratio data because we're collecting frequencies of basketball and netball shots, in which it makes it ratio, so we go down the parametric tests. And then it gives us a selection of tests to conduct. So we have the Hanover test, the t-test, the Manover, and the Pearson's test. So now we know sort of one of the 4 tests that we need to use. So we go down to this diagram. We've already determined that it was interval or ratio, which is this one. So we will follow along this route, and then we will follow the analyze of mean differences line, as we're looking to find the mean of the 2 differences of the netball and basketball shots. We'll follow down this route. And last, we will choose the independent t-test because we have 2 independent sets of data, which is here, two separate sets of data. So we need to choose the independent t-test.